Assalamualaikum and good day everyone. My name is Nadrah and from Group 4 of Engineering Statistics course. And today's video is about our group assignment that we need to analyze some data of supplement diet tablets of LAJAK KURUIH. And our group, which is Group 4, we need to analyze tablets type of B. Before we continue to the next content, I will introduce you some our group members, which is Nadrah Mustafar, which is me, that I will represent you for question A. And next is Fatin Alia will present for question C, and Syazaamanina will present for question B, and the last one is Amira will present you about question D. Okay, for the introduction of our group assignment is LAJAK KURUIH is a supplement diet tablets that manufactured by a company of LAJAK LAKU, and LAJAK KURUIH have 15 types of tablets, and each types have different health properties. And so our group managed to do tablets type of B, and from the data it shows that 200 samples observation and is taken at random 3 production shifts, which is morning, evening and night. And this data collected during the month of December of 2020. For the next table is I have 3 variables over here, and the row labels is it brings a meaning of shift, which is we have 3 shifts, right? Evening, morning and night. And then I have a count of weight and sum of tensile strength over here. So as you can see over here, I also managed to do the pivot chart, and this pivot chart is a little bit different from previous one because we have 2 data, we have 2 variables. So by doing this, we can see the comparison of 2 variables. So it's easy to read for the readers. And for the last one is it's the same as the previous one, but the difference is I use sum of relative density, and it shows that it also is really literally same with the previous one. And I think that's it for me for the question A. And I think pivot table is very useful for collecting data and summarize data, because the purpose of pivot table is also to make our works easier. So pivot table is very convenient for me to do some summarizing sample, and yes, it makes my works easier. And then thank you for and then that's it for me, and thank you for listening for my question. And then I will pass to the next member, which is Shazaa.
For question B, we need to determine whether is there any significant evidence that LAJAK LAKU tablets produced in December 2020 follow the distribution by FDA requirements. From the question, we can see that FDA requirements follow the normal distribution with mean of 350 and standard deviation of 14. To determine whether is there any significant evidence, we need to use goodness of fit test. Firstly, we need to construct frequency table for weight. So from the Excel, we can determine the minimum weight and the maximum weight. So for our data, the minimum weight is 301.31 mg and the maximum weight is 396.3 mg. Then we can create the suitable range of weight to get the frequency table by using the function in Excel, which we choose data analysis, then we choose histogram. Then for the input range, we put the weight, and the bin range is the upper limit. Then this is the frequency table that we got. After that, we define random variable x as the weight of tablets and we do test belief at alpha 0.01 level of significance. The hypothesis statement under H0, x is assumed to follow normal distribution with mean of 350 and variance of 14 squared, whereas under H1, we assume to not follow the stated normal distribution. By using the distributional under H0, then we can find the PI, which is the probability values under normal variable. As we know the value of PI, then the number of parameter P is 0. Then by multiplying the PI with the total frequency, which is 200, we will obtain the expected value EI. As we notice from the value of EI, the first, second, and the two last of the value is less than 5. So we need to combine both with their neighboring classes. Then we will obtain the new OI and the new EI. And now the EI have the expected value more than 5. Therefore, the number of classes K is equal to 6 and the degree of freedom mu is equal to 5. Now we can compare the test statistic with a critical value in the rejection criteria, where we will reject H0 if the chi-squared test larger than chi-squared 0.015 given by 15.0863. Since the chi-squared test is equal to 2.0342, which is smaller than the critical value, hence we do not reject H0. As the conclusion, we can conclude at alpha 0.01 that there is no significant evidence to support that LAJAK laku tablets produced in December 2020 do not follow the normal distribution by FDA with mean of 350 and standard deviation of 14.
Question C. Comment on whether there is any significant difference between tablet weights in milligram from the different shift. So for this question, I'm going to calculate by using the one-way analysis of variance in the Excel program, which it has a tool to calculate the ANOVA. So we go to this one. So first of all, I have categorized the weight data by shift, which is morning shift, evening, and night. So this is the level groups, and I say as K equals to 3, and this is the sample sizes, which N equals to 200. So in data analysis, I choose ANOVA single factor and set alpha is 0.01. So this is the result. So we have the summary, which it shows the count, sum, average, and variance. And then this is source of variation, which is we have the between groups, or we call it the sum of square due to treatment value, and within groups, or we call it as the sum of square due to the errors. And this is the total. Or we call it as the total sum of square. So this is the value, sum of square, and this is the degree of freedoms, where we get this value by calculating K minus 1, and for SSCE we get from this one, and SSCE, and we get from by calculating this one. And MS is the mean square. Mean square, we get this value for SSTRT, we get by dividing SSTRT divide with the degree of freedom due to the treatment value, and for MSE, we get by dividing the SSC divided with degree of freedom due to the errors. And this is the F calculated. F calculated you get from dividing the MSTRT with the MSE. And this is the P value. P value is actually a P of FRV greater than or equal with the F calculated. And this is F pre. F pre is actually refers to the upper critical value of the F distribution. Or we can write like this, F 0.012197. So we get this answer. So from this result, we can make a conclusion. And we can make two conclusion, I mean by using the p-value or the f calculated. So we state the hypothesis statement like this, and by p-value, the decision rule is to reject hash nut if p-value is less than with alpha, which alpha is 0.01. So the decision is, since p-value is 0.6553 is greater than alpha, which is 0.01, do not reject hash nut. The conclusion is, hence we can conclude that at alpha 0.01 level of significance that there is no significant difference between table weights from the different shifts. Or by using the F calculator, we set the hypothesis statement like this, same as above, and the decision rule is different, which reject hash nut if F calculator is greater than the F crit, which 4.715. So from the result, we get that since the F calculator is 0.4235 is less than with 4.715, so we cannot reject the hash nut. And the conclusion is same, hence we can conclude at alpha is 0.01 level of significance that there's no significant difference between table weights from the different shift.
For the question D, we need to determine the independent variable x and the dependent variable y. According to the question, tensile strength depends on the relative density. That means relative density is the independent variable, which is the x, while tensile strength is the dependent variable y. I'm using Excel to carry out the regression analysis to gain the fitted regression line. So I have transferred the data by going to the data analysis, and I choose the regression. For input y range, I will drag from the title to the end of the data. Same goes to the input s. Take to the residual plots, line fit plots, and normal probability plots. Click OK, and the data will be appeared. To know if our analysis is correct or not, first thing that we need to identify whether our n is correct or not by looking at the observation. Observation is 200, which is correct because our n is 200. We will gain our alpha and our beta by looking at the coefficient. Alpha is negative 0.17248 and our beta is 0.082589. The fitted regression line can be expressed as y bar equals to negative 0.17248 plus 0.082586 times s. Our question is to predict the tensile strength for the data that they give us, which is the relative density values. From this prediction, for x equals to 63%, y is 5.4434 megapascal. For x 74.3%, y equals to 5.9633 megapascal. For s equals to 80.1%, y equals to 6.4423 megapascal. We have to look at the value of the x that have been given, whether the x number, the value of x is within the range that we have. we have to find out the S mean value, which is the minimum value of the relative density is 82.8%, while for the maximum value of S is 93.4%. The prediction for relative density X values are 68%, 74.3% and 80.1% are not valid, as the prediction is only valid if the values of independent variable X is within the range.